Welcome everybody to our 14th Open Clock Club, wherever you are around the world, especially new starters. I've got a list today, so many things to get through. It's really quite crazy. So, I see. So, we've got a few things to follow up from last week, and we'll get back onto refacing pallets towards the end of the session, and and a lot's cropped up on Facebook as well. So just before we jump into it, as they say on YouTube, I've got some really exciting news about YouTube as well. Can't hardly contain my excitement. Anyway, our normal housekeeping kind of a couple of words is: one, if you want to remain anonymous, then please keep your camera turned off, because this session is being recorded and it will go on our YouTube page, our channel, which is called Open Clock Club Archive. And the second thing is, this whole session, we're one man down today on Team Open Clock Club. So Rachel will be fighting in the corner here. So please help her out with the live chat. It's been really great, again, reading through the live chat from last week and all those fantastic questions. There's so much to cover. Like, we are never, ever going to run out of things to talk about. So let's just have a quick recap on Facebook. Our Facebook page is How to Repair Pendulum Clocks, I think. So thank you all for joining in with that. It's really super friendly, and I've got my list. So some of the things we've covered this week: obviously we welcome new members as always. We've had really great input from people showing us all their fantastic new projects that they're working on, which is really great. Tools, we've had some interesting and exciting tools. Just the old glasses on so I can actually see what I've written. Oh, with a really exciting diversion into electric clocks. Ooh, and I've just been talking to John before we fired up here. And John, if you don't mind me saying, but John's working on a Sectric, a Smith Sectric at the moment. And we had a kind of AHS type mini conference thing a few years ago about the safety of mains electric clocks in public spaces in particular. And one of the outcomes of that was fitting a thermal fuse on top of the rotor or the motor, just in case things get a bit too hot. So hopefully John can take a couple of pictures of his project as it goes along. So that's quite nice. We had the, somebody said, where do you live? And again, in the live chat here, if Rachel can keep up, where do you live is always fun. More on tools, more tools. Somebody came forward with a wooden clock that their dad had made, which is really cool. Some of our spanners arrived that are made. Somebody had a clock that was so dirty, AI identified it as a form of food, which was good fun. We did how do you grind lathe tools. I don't know whether that really worked for people or not, but just the beginning, did some sketches and things. So again, let us know in feedback whether that was any good or not. And the super exciting news is we are going to start another YouTube channel. Yay, we've already got two. And that YouTube channel is going to be very, well, not experimental, but experimental for us, in as much as it's going to be a live stream on Thursday at 6 o'clock, sorry, GMT. So hopefully opening up to some people in the States. We're going to live stream, not Sectric stuff this time. So it's not really our usual thing, not Enfield stuff, sorry, not really our normal thing. But again, on Facebook, we were offered a long case clock, which is from a pub here in York, about 2 miles from where I'm sitting. And so we got that clock, we got it for free. So thank you for the people who contributed it, donated it. And it's kind of quite nice because it's sort of been untouched for at least 30 years. So we're going to approach that object by looking at how we would do a condition report and what we decide to do in terms of intervention and so on. So that's going to be great. So that's going to be Thursday. If you want to join in or drop in or whatever you do on a live stream, if the technology works, at 6 o'clock, and quite how long it's going to last, I don't know, maybe a couple of hours or something. Depends whether we actually kind of works and we get into it. So anyway, you can find the YouTube channel. It's How to Repair Pendulum Clocks live stream, rather sort of predictable name. So this evening we've got a lot to get through, and the first thing is really picking up from something last week, and that was, you may remember our Canon Pinion. If you remember this from the French clock, we noticed it was twisted, and it's striking about a minute and a half too late. You can just see there that it's kind of twisted round. And of course, you could just twist it back. Most people would just twist it back, but I thought it would be really cool to kind of show a couple of techniques here in straightening that, just to make sure that it works well. So I'm going to get on with this for a good reason, is that we're going to use, wherever it is, this material here called Polymorph. I don't know whether you've come across it. It comes in beads when you buy it. It's not that expensive. And you melt it in hot water. It's a kind of thermal plastic. You can squidge it into shape and then pull it apart when you're finished with it and reuse it many, well, presumably a near infinite number of times over. So we're going to get some Polymorph on the go, because I'm going to use it for work holding for this, which seems a little bit over the top. But we used it at the college quite a lot. I've used it to make a watch back opening tool, and it's really, I've used it to make a kind of spanner out of. So let's get our kettle on. It's good where you don't want marking, but also if you've got a really awkward bit of material. We had at college a bracket that I think had a screw that had broken off. So it was like really tricky to hold it in the lathe. So we just kind of squidged a lot of this Polymorph around it, and it was brilliant. We put it in the forge or chuck, and then afterwards you can just get it off. So that's going to be my first thing that I deal with. So I'll get the Polymorph on. So you just pour in boiling water, which is no doubt going to make the camera steam up. I'm trying to scald myself. So there you see, I won't let it steam up too much. So I just poured boiling water on. I'm going to give it 5 minutes there while it, well, melts maybe isn't the right word. But there was another question about this French clock, well, quite a lot to get into. And that was, what do you do if the friction work, so that's if, I would normally put my gloves on, but it's a faff taking them on and off. If when you move the friction work round, it's either lumpy, as in it's tight in one place and slack in another. You often find this on watches, which have got a kind of similar sort of friction work, or if in fact there isn't enough friction there. Well, in terms of the friction being lumpy or inconsistent, then I suppose I was kind of thinking about this, and what you've got here effectively are two broach taper components, one's steel, one's brass. And if they're going to be good fit together, then they both need to be basically round. Now, you could get away with one of them having a bit of a lump on if the other one was round, and vice versa. The outside one could have a bit of a lump on it if the inside one was round. So if the friction work is inconsistent or lumpy, then you can kind of sort of figure out that there's a problem with both those components, I guess. Because if they've both got some kind of inconsistency, then the friction isn't going to work properly. And how would you deal with that? Well, I suppose there are many, many ways to skin a cat. So if we're looking at this component here, the Canon Pinion, you will see in a minute that it's, as I said, it's filed to broach taper. It's not parallel inside. Not many things in these kind of clocks are. So I thought, great. This is one of the very rare opportunities where I'd be able to use a smoothing broach. Now, those people have just joined us who are new. Sorry, got a bit of a wobble on there. This thing here is a pentagonal section, a hardened steel cutting tool called the Clockmaker's broach. And we use it for the kind of controlled opening of holes. And then there's a similar taper thing here, which doesn't have any flats on it, called the smoothing broach. Some people use them for finishing bushed holes when they're making your bushes and things. I never used them, but I happen to have one kicking about. So I thought that would be a really good thing, actually, just for maybe very gently kind of smoothing out any inconsistencies inside that Canon Pinion. The other one here will be to actually put a cutting broach in, and almost sort of without actually cutting any material away, then just gently removing any burrs that have happened inside there. I suppose with this component, the biggest thing that's going to happen to it is somebody's going to get a pair of pliers on it and squeeze it here, which is maybe the cause of the problem. And then in all these thousands of bits. And then with the center wheel here, you can see this is tapered. These two things, these are not from the same clock, so they don't actually fit, but they normally fit together and they're a friction fit. You're gonna have some, probably a burr on here, I would imagine. It might be bent, of course, but I think if you look under low power magnification, what you'll probably find is that somebody has got some kind of end cutters or something on there. So I would maybe get a stone to start with. If you've got a lathe, it might help to put it in the lathe, but you'll probably find that you can use something like this, which is a dead gusset stone. It's aluminium oxide, as is this one. This is a fine aluminium oxide Spyderco branch. They're basically the same thing. Or there's a good old Arkansas stone, and you would find out where the burrs were. In fact, on this one, I can feel straight away here. There's one on a taper pinhole where it's been sort of pushed. So maybe as this has been pushed over that, it's caused some problem on the inside. Now, the key with these kinds of repairs is to go at it really, really, really steadily, because it's so easy to make what is a not particularly good situation a whole lot worse. So that's how I would sort of approach making it smooth. In order to give yourself more friction, it's so tempting to get a pair of pliers and squidge this in. If you've got, and people might cringe at this, nothing new there. If you've got a lathe collet, then I would put it in a good fitting lathe collet, like an 8mm lathe collet, and ever so slightly tighten the drawbar. That would be my preferred way of doing it, because I don't think that's going to damage the lathe collet. And what it's going to do is it's going to give you a lot of control. I think for watch Canon pinions, I'm not a watch person, there's a pair of pliers, a bit like the electrical wire strippers you used to get, that's got a screw. If any watch people out there, let us know in the live chat. So you can't kind of accidentally squidge the thing too much. So it has a sort of depth stop on it. But yeah, I would say put this in the lathe collet and just use the drawbar to just squidge it in a bit, because there's not much difference between it being not tight at all and too tight. Right, well, our polymorph here has, this is like a recipe, isn't it? It's mostly sort of gone translucent now, so that's nearly ready to use. So I'll fish that out. Got a cloth here. It was boiling water, so it'll still be quite warm. But before I do that, when we twist this back straight again, and again, I'm making a bit of a song and dance of this, but it's just to kind of show you different techniques and materials and things. There's a chance that it'll go straight again, but there's also a chance it's going to bend over at the same time, so it'll kind of squidge over, which isn't going to help you one bit. So what I'm going to do is I'm going to support it in the middle with a bit of brass wire, and you're going to say, Matthew, but you just said that it's tapered in the middle. So how on earth are you going to do that? Well, I'm going to file the wire. If I can just find a bit that's okay. So we were talking about this stuff last week, this brass wire. It's incredibly useful. You can buy sort of new old stock from poor old clockmakers that have passed on a bit. So let's just, yeah, that's okay. And you can actually see it's going a reasonable amount of the way into the Canon Pinion pipe already. So I'm just going to use a bit fine file and file that to a taper, then at least when we straighten it, there's every chance that it will remain kind of in line. As I say, it's a bit over the top, but hopefully these kind of hints and tips and things, one day you'll be thinking, you got a tricky thing to do. Ah, right, I'll do that thing. So let's just, and I need to do this first because it takes quite a long time for the polymorph to cool down. So we'll crack on with other things after we've done this. So I've got my file and I've got a pin vise. And I know, just check how much I need to file here, like that. And somewhere I've got boxwood. Let's just do a bit of filing. Our favorite thing at the moment, filing. I've now got, I'm going to do a video next week on files, on whether it's worth buying expensive files or not. I don't know is the answer. And just see if that's going to stop the camera from wobbling. And I'm going to call it Bargain Basement or Bank Breaker. So I've got the cheapest file on eBay I could find and the most expensive file on eBay I can find. It's going to be like completely non-scientific research, as everything is that I do. But we'll just be able to kind of compare the texture of them and all that stuff. Anyway, so filing's our favorite thing. So a few weeks ago, we talked about boxwood for a filing rest. So here is boxwood. It's just useful. Maybe I should start with a slightly heavier file. Shouldn't take much to get that whole thing to fit together. How's the live chat going, Rachel?
We've got 3 questions.
Oh, 3 questions. Okay, gosh. I'm bored with filing, so let's have a look at the questions. So should one draw file over smoothing broaches, otherwise they won't do much? Sam, how different is your Arkansas from a tam or shanterstone diversion using smoothing broaches, a twist arbor? Should you draw file with smoothing broach? That's a good question, actually. Maybe that's where I've been going wrong all these. It's, you know, like when you have a pivot burnisher, I don't use one of those either, so probably totally the wrong person to ask, is that you have to make the burnisher first. I think DeCal shows it. So you kind of draw it sideways on a diamond plate or on a oil stone or something to put kind of really tiny teeth on it. So I think that's a good question. The thing about a cutting broach, and I won't go off on too much of a tangent, is that it cuts with a very negative top rake. In John and I's new bushing and depthing chapter, which is finally ready for typesetting, we show the section of that, and what that means is you get a cutting and a kind of work hardening compressing action. So I'm not a big fan of the smoothing broach, but yeah, I think that could work. It's a good idea. Sam, and again, like all these things, if anybody wants to team up with the university engineering department and actually do some research on it, that would be fantastic. At the moment, I would prefer not to spend money on smoothing broaches. The Arkansas stone and the Tam O'Shanter stone are very different. The Tam O'Shanter is specifically for brass. It's quite soft. The Arkansas is for steel typically and is much harder. So they're different things. And I learned about maybe one day we'll do a thing on stones, but I learned about the Degusit stone from watchmaking by George Daniels. And I thought, oh yeah, what's that? Now this is very fine. So it doesn't remove much material, but like all those very kind of good tools that we build up over the years, when you want that thing, that little stone, or the Spyderco equivalent, the white one, is really, really good. The problem with the Spyderco one is that when I bought it, this is like a knife section, it wasn't very sharp on the edge of the knife. And then I had access to a diamond wheel, so I was able to grind it down. So that was quite useful, but they remove very little material. So Tam O'Shanter and the Arkansas took different things. And then using the smoothing broach as a twist arbor, Rob, as a twist arbor. Don't quite know what that question means. You need to elaborate a bit more on that, please. Yeah, Rob could unmute himself while I'm filing. Let's just have a look.
Why are you making a tapered brass thing? Why don't you just put that on the
smoothing broach that's already got the taper on it.
Good point. I could do. I'm just showing off as always. Just showing people how to file a broach taper, because in the bushing and depthing chapter, if you're making bushes out of bushing wire and you don't have a lathe, then it's quite useful to be able to file to a broach taper and to kind of eyeball it. But good point, John, Rob. But you'll also see in a minute that this is going to kind of get squidged inside the polymorph. But absolutely, you could. That when have I ever made something simple or easy for myself? Like never. Yeah, it's just all showing off. Right, nearly there. So when I've done this, we're gonna squidge it in our polymorph, and then we can forget about it for 20 minutes while it cools down. One little bit. Of course, what I could do, another good question and video to make is those people who've got lathes and do making and things. Here's for the live chat. Do you use engineers marking out blue, or do you use the Sharpie pen? I can see, I've never used the engineer's blue one, but I'm going to get some and do a little test with it. But I'll do it on here so you can see. So for beginners, what this does, for instance, this is just a regular Sharpie pen, is that it enables you to see where you've been or where the components are touching in this case. So when we take that off, we can see, unsurprisingly, it's touching here in the middle where the Canon Pinion is squidged in. Anybody use engineer's blue? I forget the name of it. Oh, what's the name of it? I was looking at it the other day. D begins with D.
Dicam.
What? Dicam. Thank you, Rob. Have you used it?
I wish they. I think they come in little pens, which is probably more to the scale for clockies. But usually it comes in a big bucket.
Yeah. Yeah. I mean, it looks. I think the idea of it is that Pearson Stars got stuck. Is that you can put the blue on the surface, and the surface is thick enough, the blue thick enough, that you don't actually kind of scratch the material underneath. I don't know. Right, okay. So there we are. Another reason I show you this is because if you have got your lathe, if you have a lathe, come on, and you want to hold this device, anything like this has got a taper in it, and you don't have the right collet, or you don't have any way of holding it, just put a bit of brass in a chuck or a collet and turn or file it like this. Then you've got your center here, which I actually didn't file very neatly, and you can hold it beautifully concentrically. So it's a nice little work holding device. So before I squidge it into our polymorph, it's actually a really good fit in there. I'm going to put some Renaissance wax on it. Now, I don't think the polymorph is going to stick, but just to kind of put a little sort of barrier between the two things, I'm also just out of OCD going to file a point on there as well. There we are. So that's good. You can see how they fit together nicely, so that when we twist it, it's not going to bend over. So we're just going to use a bit of, there we go. Renaissance wax, really useful product. This is paraffin wax, and just to stop it from sticking to the polymorph, like that. That on there. The good thing about Renaissance wax as opposed to beeswax is it's well, as far as they know, sort of 25, 30 years, that kind of microcrystalline wax is non-yellowing, so it doesn't sort of yellow like beeswax does. So I'm going to just throw a polymorph in here. There we go. I'm going to get it out of the pot, because I don't have a proper maybe a barrette file is the right tool for extracting the polymorph. Yay. What question?
About the Sharpie pen.
All right. Derek uses a Sharpie pen. Nick only when marking out large plates. Okay. So I think that sounds like it's. So here's the polymorph. Look, when it's in its plastic state, you can handle it. It's not. It's just warm, not hot. So what I'm going to do is just put a little bit on there. Now roll it into a ball first to make it neat. Yeah, I just wonder whether with the Sharpie pen, whether maybe they do. Some people might look down their nose at that. I've always used the Sharpie, so it'll be interesting to see. Now with this, it's going to take quite a few minutes to kind of cool down. So I'm just going to put it on there. I don't want it to be too closed in, otherwise I'll never be able to get the wheel out, which would be moderately unfortunate. I have made a video of using this stuff, but as I said, for holding a watch case, which was really good actually, without scratching. So we'll put that to one side, let it cool. Hopefully it doesn't flop over, and come back to it in a minute. So our French clock, where's my list gone? Where are we? French clock, yeah, questions about that from last week. You will remember that we were talking about, of course, we've lost our Canon wheel now, so let's not worry about that too much. But we were talking about the nose of the rack arm here getting stuck or jamming on the radial face of the stepler snail. And one of our YouTubers wrote in and said, I'm to make sure that can't happen, because of course, even if you set the striking up correctly, if for any reason the striking train runs down before the going train, then the clock's going to jam. And he said he was going to put a bit of oil on there, which is absolutely fine. But I think it's one of those places that would be really good for a bit of graphite or dry lubricant on there. But if you remember a couple of weeks ago, we had Dale kindly talking to us about the Vulamy clock. And on that clock, there was a thing called star wheel and jumper, where you have a kind of knuckle device that indexes the snail. And again, those long bearings, because the problem with putting oil on a long bearing or a bearing with, sorry, you admitting these people? Yes. Okay. Along with a long bearing with oil, is as soon as the oil starts to thicken or go a bit gloopy or sticky, then you're going to get a fail. So what I would use is an artist's graphite pen, which I don't have. So I'm just going to use a 6B pencil. This is my favorite brand of pencil. And that's a really kind of useful tip, which name dropping here. I learned that from Anthony Randall. There's a similar thing here. This is also a 6B sort of artist pencil, but if you just got something that's a little bit sticky, then that's a nice way of lubricating those surfaces without that ever going like gloopy or gluing together with oil. So top tip there. In our long-awaited and bushing and depthing chapter, that's another good tip. If you've got a pinion that you think is butting, all explained in our chapter when it comes out, then as a kind of temporary measure, you can put a bit of graphite on it to check that your kind of hypothesis is correct. Okay, so that's another thing off my list. Right, okay. The next thing, it's just something, a totally incidental point really, is that last week we talked about the dot alignment on the hour wheel and the Canon wheel and the minute wheel, getting those things right. But I remembered after that there are also dot marks. The light's a bit gloomy, isn't it? I'll just turn that up a bit. There are also dot marks inside here, which are quite difficult to see. There we are. But on the pinwheel here, you can see the pins in, but there's actually just there a little dimple. And this is really useful when you're setting the clock up. If you find, if you're working on a pendule and the striking is locking when the hammer's been lifted, that's probably your problem. That little dot mark there aligns with one of these pinion leaves on the stop wheel, so one of these. And how you know is that when you look really closely, sorry, I'll hold it still. When you look really closely, the shoulder of one of these pinion leaves almost all the time has been filed away a little bit. Sometimes it's quite obvious and sometimes it's really subtle. But if you know about that, when the clock obviously doesn't have any power on the mainspring, remove this pont here, so you can take the pinwheel out of engagement with the stop wheel, align that dot and that mark on the pinion leaf down there, and your striking problems are pretty much over in that respect. And the last thing on the French clock was I got a comment about pin removal, because I was kind of just thinking on my feet last week, and I whipped out taper pin with my cutters. So here's the kind of philosophical question that the kind of thing that Rob is particularly keen on engaging with, and that is, are pins, taper pins, are consumable, or are they part of the integrity of the object? Does the object know, does it have a kind of sense of those pins being there and you changing them and so on? Now, I tend to change pins just because I'm kind of a bit lazy, but you do sometimes see 19th century clocks, these Ponjos and others, that you think, yeah, they're probably the original pins. Not that that makes a massive amount of difference. And I've seen one 18th century object where I'm pretty sure the pins were original. They were draw filed and they were silver, so that kind of set it apart. So how do you get the pins? How do you get the pins out? Right, we've just got some questions coming in. Move over for entirely graphite-based lubrication. Well, if you use, maybe there was a big kind of like excitement a few years ago about diamond nano lubes. I never got into that at all. I don't know what happened to them. Presumably there's something that was developed for industry. The problem with something like that is it's getting it off if you decide it's a bad idea. And of course, if you use D3, I don't know what oils you all use. The most popular question on all clock fora, internet fora, is what oil do you use? Well, if you use Mobius D3, that's got molybdenum disulfide in it. And as far as I understand, but again, the beginners, is that that's an oil, but it's also got molybdenum disulfide in it. So you get two elements of a compound or an element that actually kind of adhere to the bearing surfaces and keep those bearing surfaces apart. And the question is, could you move over to an entirely graphite-based lubrication for a whole clock? The answer to that, I'm afraid, is the answer to loads of these things in clocks, ultrasonic cleaning, you name it. It needs research. And again, I'll say the same thing. I'm sure professionally, somebody who's watching this video is involved or works for a university, engineering department or organic chemistry or whatever, get involved with a research project, please, because we'd love to know. And I really don't know, but I do know that there we are, searching around for it. D3, Mobius D3 has got molybdenum in it. And we've got one attendee who uses LPS1 greaseless lubricant. What do you think about it? Is that on the mainspring or is that on the train wheel pivots? I don't know is the answer. I'm afraid I've been really lazy in that respect. Again, I've basically got onto the Mobius D series lubricants for train wheel bearings, and I don't do watches at all, so I'm only really clocks, and I always use either D3 or D5, sometimes D1, and we use a liquid spray grease with molybdenum disulfide on the mainsprings, which I think we show in our book 1. So that's kind of dealt with that. Lots more. I mean, yeah, we need to talk to a chemist about lubrication. I think good question. It's probably it with our French clock for now, and our polymorph is getting there by the look of it. Yay! Sorry, don't want a break. Let's just do this, then we can. Oh gosh, tempus fugit. So here we are. Moment of truth. We've got our little work holding device, and yay, we can actually get it out as well. That's good news. So you can see here, I mean, as I said 3 times now, slightly over the top, but if you've got a really fragile component that you want to hold, and you don't want to kind of, you see so many things clamped in 3-jaw chucks and so on, this is really useful. Now I've made a spanner here, and another top tip, thought I'd roll as many things in as possible. Made this little slightly too fancy looking spanner, but there's a reason for this, and it's the 1 in 57.3 rule. The John will put me right on this, but 2 pi radians equals 360 degrees. Basically what it means is if you go along 57.3 or about their units, it doesn't matter whether the millimeters, feet, miles, you name it, and go across 1, that's about 1 degree, and that's useful for small angles. And I saw the other day that pilots use it. They call it the 1 in 60 rule. So if you fly along 60 miles and you're either 1 mile off or 1 degree off, you know that's 1 degree or 1 mile. Anyway, so here I've done it for about 7.5 degrees, which was the amount that my hand was off. So when I put this on, we can make a mark here with a Sharpie, and I can twist it back, and hopefully the thing will work. But anyway, it's definitely time for a break. Just trying to see what time it is. It's 36.5. So well, we haven't got long. So let's just have a quick break and come back at 38. Okay, might only be 2 breaks today. So a couple of questions coming in the break there. No rest for the wicked, as they say. Why is Decal so sniffy about brass pins? Well, everybody kind of is, or maybe was then. I mean, there's an interesting conversation to be had about Decal, which we should probably have offline. But yeah, anyway, steel pins for clocks or iron pins for clocks, brass pins for watches. And presumably there's good technical, mechanical reason for that, but I don't really know what it is. There is the issue, of course, of like materials sticking together, of micro cold welding and then galling, and that is a real thing that happens. There was a regulator with, you know, have you seen those astronomical regulators with a really big brass screws, headed screws that got a small shank? One of those, it wasn't me, thankfully, but it was a really well-respected conservator, and the screw just got stuck in the hole, and of course the more you try and get the thing out, you put oil on it, whatever, it's just welded together and then it begins to gall. So maybe it's that with the brass pins and the clocks, that would be reasonable. But why brass pins for watches are okay? You know, when I'm saying watches, I mean what people call pocket watches. And I don't know. Again, thoughts, please. And then the other question was about the stones. They were always banging on about these different stones, and I never get around to listing them. So, promise, next week when we begin, we'll begin with bring along a stone. So, will you all bring along your favorite stone, please? And we'll go through. I don't have loads, but I've got oil stones and things which I don't use. So let's talk about that. Anyway, you might have seen in the break, I straightened up the Canon Pinion, so there it is. Still looks slightly twisted across here, so it might need a little bit more, but I won't do it now. I'll deal with that during the week and tell you if it's been successful or not. So pallets, looks like it's our first one break week. These pallets, as you can see, have already been refaced. This one with a bit of spring, which is actually cracked on the end there, and on the inside, so thin spring there. Now, the advantage of doing it with spring, of course, is you can get the stuff really thin. And as I've said before, what happens is the escape wheel wears smaller diameter. You don't kind of see that. So if there's what you think of as excessive drop, you can get a bit of mainspring in there. If you can only get spring on one side, as I said a couple of weeks ago, last week, you can deal with that with just by leaving that spring a little bit longer. But it does, of course, then very, very fractionally upset the geometry. And what we want to do here, let's see if I can just move my physog across. No, I can't. What we want to do here is to maintain geometry. So we're getting away from bending the pallets. So anyway, there's either glue on some or solder on some mainspring, or do the same thing with a bit of gauge plate. For people who are just joining us this week, we looked at this last week, which is ground flat stock. Let's just zoom out a bit. Also called gauge plate, which is a high quality tool steel. As you can see, it's got all sorts of junk in it here, but it hardens like crazy. Or we can use a bit of old blued steel spring. I said last week, don't use the modern brown spring, because it's got all sorts of stuff in it that seems to stop the solder from sticking. So let's say, for instance, we're going to reface with this blued steel spring here. You can, of course, just cut a piece off, stone it, or diamond, with a diamond file or something, get it down to size and solder it on. The problem is you don't know how hard this is. I think we did the little thing of snapping a bit last week. So it's pretty hard. But what I tend to do is to harden it dead hard first. Well, actually, that's what we're going to show here. So in fact, what I do first is to anneal it completely, because if you look at this entry pallet, for instance, it's ever so slightly curved. And so we want to kind of replicate that best we can. And it might be that you find a bit of spring that's kind of the right curve and you can soft solder it on. But I think for me, I prefer to anneal the spring, which we're going to do now. We're going to, having had the kettle on, we're now going to try and set the place on fire. And then you can fit it by soft soldering it on. You can shape it, and you can just leave it fractionally too long, so the escapement just doesn't work. If you poor people there who've made an escapement from new, you'll know that that's how you do it. You kind of get it so it just doesn't work. So there's zero drop. You make the thing, you harden it, you polish up all the surfaces, and then at the very, very last minute, you just use a diamond file or something, or a stone, just to generate drops. I'm looking around now for something. I've got gas. Where to put the soldering? Can't be far, as the saying goes. It's that square board with the blocks on it. Sorry, we're just looking around for something now. There. Just hiding under a mountain of disassembled clocks. So let's just take a bit of spring. Again, this is just for demo. It's a little bit narrow. You could get away with that, of course, because the escape wheel doesn't cover the whole of the pallets. But I'm just going to find something that's a little bit wider. Had a bit last week. Right. So again, this is really a bit over the top for this process, but we've got our piece of blued steel there. The gauge plate, by the way, which is here, the ground flat stock, I've cut a piece down. You don't need to anneal that first because it comes annealed from the manufacturer, but it comes in ground. So it's surface ground, beautifully sort of flat, but with a ground surface, which we don't want. So what I've done is I've stoned it off this side with the ceramic stone to get it reasonably kind of smooth and shiny. So that's already annealed. You can work that to size. It's really kind of sticky to work, but no problem there. So we're just going to light up here. Matches. You just pass. Can you get up, Rachel?
Yeah.
We just pass that piece, that orange torch there, that little clicky one.
Yeah.
So we just heated that until it began to glow a bit quick, but glow sort of orange. And then what we want to do when annealing the steel is to allow it to cool as slowly as possible. So a very different process from hardening it. So I've just left it under there for a few minutes. And what we're going to do in the meantime is to get our spring steel that's on here off. Let's say this has reached the end of its life. And people have commented that this is why they don't like this method of putting the mainspring on, is because it's relatively thin. It's going to wear through and ruin the escape wheel, which I suppose in extreme cases that might be the case. I don't know. I've never seen it that badly worn. This has only been running a couple of years, but anyway, I'm going to remove it anyhow. But I'm not going to heat this up. I'm going to heat it up, but not with that blowtorch thing. This is where your spirit lamp is incredibly useful. It's really, if you haven't got one of these, get one of these, because if you're doing soft soldering, it just allows you that kind of luxury of just allowing the heat to come up, particularly useful for things like tempering, but great for soft soldering and so on. Unlike this kind of thing, which are dead convenient, but just totally make life difficult when it comes to soft soldering, but good for lighting your spirit lamp. So my camera melts. Okay, let's just move that away a bit, in fact. So to get soft solder off, now soft solder is often, you know, described as bodgery and bad this and bad that and whatever, yeah, whatever. But it's not. Learn to soft solder neatly by tinning both sides. Again, we can do a demo on it. In fact, we've got a handout somewhere, probably in our next book, I think. But soft soldering is incredibly useful process and perfectly legitimate. All kind of, most wheel collets are soft soldered on their arbors anyway. So what we're going to do here to get soft solder off is use a Glasgow brush, which is a natural, really important that it's natural bristle here. This is a number 2 Glasgow brush, and you can see I've had it soaking in water. So if you've ever had that experience of getting a repair that's had like loads and loads and loads of soft solder on it, and you want to get some of it off, you can heat up the component with your spirit lamp and then brush off the solder. But of course, if the brush is dry, it kind of sets on fire. Whereas if the brush is slightly damp, then it doesn't, and it works really well. So let's just move back. How are we doing for time, Rachel? Let's just move back here and there. So what we want to do here, of course, is to heat this part of the pointy stick somewhere. Here it is. We want to heat this part of the pallet, but we don't want to heat the whole pallet frame so much that we disturb this joint here, because this joint is also soft soldered where the collet is on the arbor, as I just said. Now, what you could do here is, now I've put it in these jars, which are not going to help as a heat sink. You could use a bit of cloth that's been soaked in water, or you could use potato, which is what the old people used to use, and on the old days, should I say. Or there's a even better, there's a product used by jewelers for soldering called cool gel. So you would maybe want to use that, which is much more useful. I'm going to just use a bit of cloth. You'll often see pallet frames like this that have been really heated and they've gone all blue and yucky. So we want to, you know, avoid that if we can. So I'm just going to put this bit of cloth around, which should work as a heat sink and prevent that collet from getting too hot. So using our spirit lamp, we're just going to heat this. And you've got to be quite patient with soft soldering. So we're just going to try it. It might take a few minutes just to get up to temperature, but I'd prefer it to do that than to use the little creme brulee torch thing. And oh, there we are. Perfect amount of yakking there. Well done, Reed. Good, happy with that. So without overheating the whole thing, we've got our solder off, and you can already see that that's going to be really useful to us when we're going in the other direction. Let's just have a little look at that, see how blue it's gone, if at all. You should be able to keep the pallet frame under the temperature of it turning blue. So maybe a little bit there, look on the corner, it just started to go, but happy with that. So you can see under here where the old wear was. Now, I don't think these were probably taken down. So whether they actually needed refacing or not, I don't know. So let's go back to our little bit of steel here, which hopefully cooled down now. Yep. And this, remember, it snapped before really easily. Oh, I never talked about taking pins out, did I? I got completely distracted by this. It's soft now, so you can just bend it round. Okay, so the annealing has worked. Now I'm just going to flatten it out a little bit, and then we can clean it up. And maybe if we've got time, 54 might have run out of time. Just get the little block for. More questions?
More questions?
So we've got more questions. So thank you for keeping the live chat going. Just going to flatten this bit of steel out a little bit. There we are. So now we actually want it to be a bit curved, but what I want to do first is to clean up this surface here, so I can actually get some soft solder on there and solder it on. Now I could do that with the ceramic stone. You know, I'm not much of a fan of abrasive paper, but you could use abrasive paper on there, or I could just use a little bit of steel wool. So I'm just going to try a little bit of steel wool and see if that gets us close enough.
You look at these questions after you've finished.
Really?
Yeah. Keep going.
That's not going to get it clean enough, so we will in fact have to move over to a stone. Let's just, oops, sorry, can't see that. Nice little hammer, by the way, American. What are the questions, Rachel?
You clamp up the frame with the brass between the nib and the collet.
Did I what?
Could you clamp the frame?
Oh, you could clamp it here to yeah, to act as a bit of a heat sink. Yeah, that would certainly help. I was just again being a little bit lazy. Right. Yeah, we're getting there. A little bit more. Again, I showed in that video where I made the spanner tool that a cork block is really useful. Sort of just a general decorator's cork block for putting things on when you're filing them flat. But it's great like this, where you've got a small component that you struggle to hold. A little bit more. It's probably getting clean enough so we can solder it on. Now remember, we don't actually want this bit to be totally flat. We want a slight curve in there. So water on that stone. These ceramic stones use with water, which is quite nice because they don't get too sort of yucky when you're stoning things. Let's put that in the right place. So wherever our pallets have gone, we now want to just try and, gosh, it's actually, now I look at it, it's really very, very flat. Let's have a look. No, but we've got our steel bent the wrong way, so. And this is, again, the great thing about it being annealed is you're not tempted to kind of say, oh, that's close enough, the curve of that spring is fine. You can continue to work it and it's very soft, so it's not at all a problem. Right, a little bit too. There we are. Okay. So what I'm going to do now is, although this has got some soft solder on it already from the old repair, I'm going to do that again and what they call tin it. So again, for beginners, if you haven't done soft soldering before you put your two surfaces together, you cover them with a thin layer of solder, and that just makes, it's called tinning, and that makes life a million times easier. So that is going to be our next stage for next week. So basically, I'm going to put that on there, cut it down to size so it's fractionally too long and the escapement doesn't work. Take it off, harden it dead hard, so quench it in water and not temper it back at all, just leave it dead hard, and then stone back at the last minute to get the thing working. So it maybe seems a bit of a faff, but of course this is going to last decades, if not many decades, so it's worth spending a bit of time on. And just before we go, because we run out of time, I just want to talk about, if I can find it, which I maybe can't. Oh, here we are. Little repair that we've done this week on a clock for a client. We talked about brass and annealing and the ability to anneal and work hardened brass. So this was a bit of CZ120 that I used to make this fly spring, and but I hammered it first to make it really as hard and as springy as I could, and so we can again delve further into the mechanical hardening and annealing of brass, but it just means that you can actually feel it's really good and springy. Anyhow, so there we are, covered a lot of ground. Hope everything's okay. We have got much to catch up with on the live chat. We've got any more questions to round up before we go?
Jane, could you use a spirit lamp? That one.
So we've got, could you use a spirit lamp to anneal, or do you need a blowtorch? No, you won't be able to use a spirit a lamp to anneal. You have to get steel up to that dull red or even hotter sort of bright orange color. Spirit lamp for tempering, definitely. So that's bringing it up to temper colors, sort of from come on brain, blue, sorry, pale straw, dark straw, blue, purple blue, pale blue, and then gray colors. Well, that's a different temperature range altogether from the heat you'll need for annealing. So you need both methods of heating. Electronic solder sucker may be useful. Yeah, well, this is really John and Rob's field, and they can chip in here maybe next week for solder wick. There are those things called like a little vacuum pump thing as well, aren't they, for getting the solder off? Is it solder wick or vacuum pump, Rob, John? Oh, they're both on mute. Anyway, next week, let's deal with that.
Solder sucker.
What?
Solder sucker.
Solder sucker, what's that?
The thing with a pump.
Oh, that's your favourite, is it? Are you with
Oh, no, I see. Well, my favourite one is the wick. It's the,
right, okay.
Right.
Right, good. We could do with a little demo of that then sometimes, please, John, or Rob, or anybody else who's into electronics. Anyway, there we are. We'll leave the live chat open until 5 past, which is only another couple of minutes. Hope that was of use. Usual thing, a bit of a romp through quite a lot of stuff there. Keep up with us, please, during the week on YouTube and on Facebook. Everything crossed, we'll have a couple of new videos out this week. Got some clocks to fix first. And all being well, we'll see you again next week. And thank you very much for joining us. Thank you.